Welcome to Deep Tech Dharma, an autonomy thesis. You know, we live in a world where robotic arms are just, frankly, marvels of science fiction. I
Absolutely.
mean, they can weld a car frame in, what, a fraction of a second?
Yeah, moving with this level of superhuman speed and precision that is almost terrifying to watch sometimes.
Exactly. It's wild. But if you take that exact same multi-million-dollar robot, hand it a simple screw, and just ask it to push that screw into a hole without accidentally crossing the thread, it'll probably fail.
It will almost certainly fail.
Yeah. Yet a 2-year-old child can just do that effortlessly. So welcome to the deep dive. Today we are opening a dossier on the absolute cutting edge of advanced manufacturing.
It's a fascinating one.
It really is. We're looking at a deep tech startup out of India named Cynlr, which stands for Cybernetics Laboratory. And our mission today is to explore how solving this one specific, incredibly stubborn paradox in robotic vision is basically about to rewrite the rules of who gets to manufacture goods globally.
And that robot versus child example is just the perfect paradox to frame this entire discussion. I mean, the inability of robots to adapt to slight changes in their physical environment.
Like actually seeing what they're holding.
Exactly, to actually see and understand what they are holding in real time. This is a 40-year-old failure in the industry.
Wow, 40 years.
Yeah, it's often referred to as the holy grail of robotics. And while it sounds like a highly specific engineering puzzle, this single limitation is basically the invisible ceiling capping what every country on Earth is able to build.
Right, and how much it costs to build it and how long it takes. And the goal for us today is to really bring this down to earth, if not.
Because it really does affect everything.
It does. We're going to examine how fixing these fundamentally, well, dumb machines isn't just some exercise in making flashier tech. It is going to change the physical goods sitting in your house right now.
Right, it means manufacturing moves closer to home.
Custom products become drastically cheaper. And on a macro level, it fundamentally changes what a country like India can produce for the rest of the world.
Absolutely.
But to understand the fix, I feel like we really need to understand why these massive multi-million-dollar machines are essentially blind in the first place. Because, I mean, if you watch footage of a modern car factory, the robots don't look blind.
No, they don't.
They look like they know exactly what they're doing.
They look that way because their environment is curated down to the literal millimeter.
Okay, so it's all staged.
Pretty much. Modern factory robots operate much less like intelligent workers and much more like highly advanced barcode scanners.
Barcode scanners, wow.
Yeah, I mean, they do not comprehend the objects they are manipulating. They rely entirely on pre-taught, totally rigid motions.
So everything has to be perfect.
Everything. The lighting, the placement of the tray, the orientation of the part, it all must be absolute perfection. The second anything changes on that factory floor, they freeze.
Like what kind of change?
Say a part is slightly rotated, or a stray shadow falls across the workstation, or a screw is dropped. The machine just stumbles.
It just doesn't know what to do.
Right. It has zero capacity to understand the physical world dynamically.
So if a factory manager opens a loading dock door and the afternoon sun hits the assembly line at a weird angle, that could theoretically throw off an entire automated system.
Oh, it happens all the time.
You're kidding, just the sun.
Just the sun. And that exact vulnerability is what Gokul N.A. and Nikhil Ramaswamy, the founders of Cynlr, experienced firsthand.
Right, because they were working in this space already.
Yeah, before starting this company, they were engineers at National Instruments, dealing heavily with machine vision technology on live factory floors. And they confronted this just brutal statistic.
What was the stat?
Out of every 10 factories that attempted to deploy vision-guided robots, 7 of them eventually just abandoned the project.
Wait, 7 out of 10, a 70% failure rate.
Yeah. The technology was simply too fragile for the chaos of real-world manufacturing.
A 70% failure rate for massive capital investments. I mean, you can't sustain an industry on those numbers.
You really can't.
Yeah.
So instead of just accepting that, they decided to grind it out.
Right. The dossier mentions they spent years solving over 30 distinct vision problems that major clients, companies like GE and Timken, had basically written off as impossible.
Yeah, they called them impossible for a reason.
I'm imagining these aren't just simple lighting tweaks then.
Oh, far from it. We're talking about tasks like identifying a specific shiny metal gear buried in a bin full of identical shiny metal gears.
Oh, that sounds like a nightmare.
Right. All under harsh, unpredictable factory lighting. Or trying to get a machine to handle a part that is partially transparent.
Okay, yeah, that makes sense.
And through that intense crucible of solving one edge case after another, Gokul and Nikhil realized something foundational.
Which
You
was?
couldn't just write better software or slap a higher resolution camera onto the same old sensors.
It was a dead end.
Total dead end. They realized they had to rebuild machine vision entirely from scratch.
Okay, let's unpack this a bit, because I keep picturing a dancer.
A dancer.
Yeah, essentially, a factory robot today is like a dancer wearing a blindfold who has memorized this beautiful, incredibly complex routine.
I like that, yes.
It looks breathtaking, right?
Mhm.
But the second someone accidentally kicks a prop onto the stage, the dancer trips, the routine is ruined, and the whole show stops.
That is exactly it. The dancer has zero spatial awareness outside of that memorized choreography.
Right.
And the traditional approach that the tech industry took to fix this blindfolded dancer problem was, well, essentially just asking the dancer to memorize more scenarios.
Just giving them a bigger script.
Right. In robotics, this basically meant trying to feed an AI this massive database of millions of 2D images. The logic was, if the AI sees enough static pictures of a screw from every conceivable angle, it will eventually understand the screw.
But wait, why doesn't that actually work? If I show an AI a billion pictures of a screw, shouldn't it be able to recognize it when it sees it on the assembly line?
Because that just isn't how spatial comprehension works in the real world.
What do you mean?
Well, a 2D image is just a flat grid of pixel values, right?
Yeah.
If you train an AI on a million photos of a screw under white fluorescent light, the AI learns those specific pixel values.
Okay, so it memorizes the white light version.
Exactly. The moment a yellow bulb is used on the factory floor, or a machine casts a shadow over that screw, all those pixel values change.
Oh, wow. So to the AI, it's totally different.
Right. The AI doesn't see a screw in a shadow. It sees an entirely new, unrecognizable configuration of pixels, and it just throws an error.
It trips on the prop.
Exactly.
Right.
Which is where Cynlr's core insight comes in. If memorizing billions of flat images doesn't work, how do you teach a machine to actually see?
You look at how biology does it.
You look at human neuroscience, yeah, and evolutionary biology. A human baby doesn't learn about the world by staring at a static flashcard of a toy from one angle.
No, they grab it. They throw it.
Right. They move it around, they rotate it, they feel the weight of it, they look at how the light hits it as it turns. They might even put it in their mouth.
Yeah, definitely the mouth.
They integrate motion, depth, and touch, all in real time. They're actively engaging with the physics of the object to figure it out on the fly.
Okay, so Cynlr decided that for robots to succeed, they had to be taught to learn dynamically, just like that baby.
Precisely. And to achieve this, they built their own proprietary vision stack from the ground up, called CLX E01.
And based on what we're looking at here in the dossier, this is not just some off-the-shelf camera wired into a laptop running clever code.
No, the CLX E01 system fundamentally alters the hardware approach. It mimics the human eye's ability to perceive motion, depth, and color simultaneously.
How does it actually do that, though?
One of the key ways is through a technique involving lens convergence.
Lens convergence.
Yeah, traditional 3D vision in robots usually relies on stereoscopic cameras, essentially two separate cameras sitting side by side taking flat pictures.
Like our two eyes.
Kind of, but then a computer has to do a bunch of heavy math to cross-reference those two flat pictures and guess the depth. It is computationally heavy and very, very slow.
Whereas Cynlr's approach physically mimics how our eyes actively focus.
Yes, by using lens convergence, their system dynamically shifts its focus, just like the tiny muscles in your eye, integrating depth and motion natively.
That's incredible.
The performance leap is massive. They achieve depth perception that is roughly 10 times faster and at 3 times the resolution compared to those traditional stereoscopic methods.
10 times faster.
Yeah. The robot can look at an object it has literally never seen before, instantly understand its 3D geometry, and adjust its robotic grip in real time without ever needing a database of training photos.
Okay, but wait, transparent and reflective objects. Earlier you mentioned the nightmare of shiny metal gears or clear plastics.
Yes, the glare problem.
Right, because if I'm looking at a glass of water in a sunlit room, my human eye automatically adjusts to the glare so I don't go blind. Is Cynlr's technology mimicking that exact biological response to avoid getting blinded by a shiny factory part? The dossier mentions something called event imaging.
Spot on. Event imaging is this brilliant workaround for the glare issue.
How does it work?
Well, a normal camera works like a flipbook, right? It takes full-frame pictures over and over. If there's a massive glare from a shiny metal part, that entire frame blows out to white, and the robot loses the edges of the object.
It's blinded.
Right. But event cameras operate entirely differently. They don't take full frames. They only register changes in light at the individual pixel level.
Wait, so it's tracking movement in contrast, not taking a photograph?
Precisely. It works much more like the biological optic nerve. If a metal part has a harsh static glare on it, the event sensor essentially ignores the static brightness.
Oh, because it's not changing.
Exactly. It only processes the dynamic edges and features of the part as the robotic arm moved it. It doesn't get blinded at all.
That is so smart.
It can handle highly reflective metals and completely transparent plastics just as easily as a matte piece of cardboard.
Wow.
This sensor package is actually so robust that it is even being discussed as a potential alternative to the incredibly complex, expensive setups of radar, lidar, and cameras that self-driving cars currently rely on.
Oh, that's a whole other deep dive right there.
It is, but Cynlr is keeping its primary focus squarely on transforming the factory floor for now.
So let's talk about that transformation. We have this technology, and it's physically integrated into their flagship dual-arm robot called Cyro.
Cyro,
So you have this two-armed machine with these highly advanced camera eyes that possess what they call object intelligence. When you put a machine that can actually see into a manufacturing environment, it doesn't just change the robot, it changes the entire architecture of how we make things, right?
Oh, it completely shatters the current paradigm. It shatters the gigafactory.
Break that down for us.
Let's look at how the biggest companies in the world operate right now. If a major automaker wants to release a new electric vehicle, they have to build a gigafactory.
Right. Billions of dollars.
Billions of dollars in capital, years of pouring concrete, setting up massive assembly lines. And that factory is entirely rigid. The machines inside are bolted to the floor, custom tooled, and locked forever to making that one specific car model.
Because the robots inside are those blindfolded dancers.
Exactly.
They only know the routine for the 2025 sedan. If you want to build the 2026 SUV, you essentially have to tear the floor up.
The cost and downtime of retooling those factories is just astronomical. But Cynlr's counter vision to the gigafactory is what they call the universal factory.
A universal factory.
Imagine replacing that one massive rigid plant with clusters of reprogrammable microfactories. Because the Cyro robot possesses object intelligence, it doesn't require custom metal fixtures to hold parts perfectly still.
And it doesn't need months of reprogramming for every new component.
Right. It can look at a pile of loose parts, figure out what they are, and just assemble them.
So what does this all mean for us? It sounds like they are turning the physical factory into a smartphone.
A smartphone, that's a great way to put it.
Right, because you don't buy a new phone when you want a calculator. You don't buy a separate compass and a separate camera. You just download an app.
You just add the software.
Exactly. With Cynlr, you don't build a new factory for a new phone. You just download a new capability to the robot.
You are turning deeply rigid hardware into highly adaptable software. And the implications for everyday people, for you and me, are profound.
How so?
First, flexible manufacturing means production can be localized. We currently ship raw components across 4 different oceans, simply because the only gigafactory capable of assembling those specific parts is on another continent.
Which is terribly inefficient.
With microfactories, a company could assemble those products in regional hubs, vastly cutting down global shipping emissions.
And honestly, we all learned a very painful lesson recently about global supply chain vulnerabilities.
We certainly did.
When a single canal gets blocked, or a few major ports shut down, you suddenly can't buy a refrigerator or get parts to fix your car. Decentralized manufacturing builds resilience against those shocks.
Absolutely. And it also completely democratizes who gets to make things.
Like smaller businesses.
Yes. Under the current gigafactory model, if a small business or an innovator wants to produce a custom, specialized physical product, say, a highly ergonomic medical chair, they are priced out of automated manufacturing.
Because assembly lines are only profitable if you are making millions of identical units.
Right. But a universal microfactory could affordably assemble a batch of 500 chairs on a Monday and then seamlessly switch to assembling high-end coffee makers on a Tuesday.
You completely eliminate the barrier to entry for making physical goods. And you drastically reduce industrial waste because you aren't scrapping an entire assembly line's worth of machinery just because consumer tastes change.
Exactly. The machines just adapt to whatever the consumer wants next.
Yeah.
And this naturally leads us to look at the global power dynamics at play.
The geopolitics of it all.
Because if manufacturing becomes as flexible and decentralized as downloading an app, It entirely disrupts the massive monopolies that currently hold the power to build things in this world.
Right, the dossier outlines this tight foreign automation monopoly.
Yes. The robotics and the vision systems that run almost all of the world's major factories right now predominantly come from a small, elite club of massive corporations located primarily in Japan, Germany, and the United States.
Which means if a country wants to build its own sovereign manufacturing base, if they want to be totally self-reliant, they're still entirely dependent on buying those rigid machines from that foreign monopoly.
And if you are reliant on someone else's closed ecosystem, single-purpose machines, you do not truly control your own manufacturing capabilities.
You're capped.
You are capped by what they are willing to sell you and how they allow you to use it. You might be able to assemble things on your soil, but you aren't truly sovereign in making them.
And this is where the impact on India becomes so central to this story. Cynlr is completely flipping the traditional narrative of how a country breaks out of that dependency.
They really are.
Usually, when we hear about a nation trying to build deep tech sovereignty, whether it's in semiconductors or aerospace, there's a massive government entity behind it, right? State funding, defense contracts, massive grants.
But Cynlr is doing this in the private sector.
Wow.
They've raised about $15 million in total venture funding, including a $10 million Series A in late 2024. By competing on the global, privately funded stage, they are actively taking a sledgehammer to what is often called the India discount.
The India discount. This is this deeply ingrained kind of lazy bias in the global tech community, right?
Unfortunately, yes.
It's the assumption that an Indian deep tech startup is only building localized solutions for the Indian market. The stereotype is that they are just building a cheaper, slightly rougher version of a Western technology rather than pushing the absolute frontier of global science.
And Cynlr is aggressively proving that assumption wrong at every turn. I mean, they established a massive 13,000 square foot research lab in Bengaluru called the HIVE.
The Hub for Intelligence and Vision Excellence.
Right. It's one of the most advanced robotics labs in the region. They didn't stop there either. They opened a design and research center in Switzerland to collaborate directly with European neural research institutions.
Oh, that's a serious footprint.
And most importantly, their early customers aren't just local firms. They are partnering with the absolute titans of global manufacturing. We're talking General Motors, Ford, Denso. They recently showcased their Cyro robot heading toward Audi's production lines.
But here's where it gets really interesting, and I want to challenge this a little bit.
Sure.
We're talking about a 70-person startup with a $15 million war chest. The entrenched global automation monopolies in Japan and Germany have tens of thousands of employees, billions of dollars in R&D, and 40 years of deeply entrenched relationships with these exact automakers.
They do.
How does a small team of 70 people in Bengaluru realistically take them on using just venture capital? Isn't that an incredibly risky wager?
It is an incredibly risky, audacious wager. And I think we need an honest reckoning of what Cynlr is attempting to do here.
Because it's not a done deal.
Not at all. We cannot paint this as a finished, perfectly polished victory. The reality of the factory floor is brutally unforgiving.
Right.
Making a robot look amazing in a highly controlled, high-profile demo, even when they presented at the UN AI for Good Global Summit, which was huge, is one thing. Translating that demo into millions of consecutive, reliable, error-free hours on a live, chaotic production line is a completely different universe of difficulty.
Right, because if the machine drops apart once every 1,000 tries, that might be fine in a lab. But on an automotive line producing thousands of cars a day...
That failure rate is a total catastrophe. And the sales cycles reflect that sheer difficulty.
They must be incredibly long.
Deploying a completely new, paradigm-shifting vision system onto a critical production line isn't a quick software update. It takes anywhere from 12 to 24 months of rigorous testing, integration, and validation.
A year to 2 years just to deploy it.
Yeah. It requires serious capital, endless patience from the client, and an incredibly high tolerance for solving unforeseen edge cases.
So how do they survive that gauntlet against companies 100 times their size?
Their entire philosophy comes down to a specific wager, that first principles depth beats incremental shortcuts.
First principles depth.
Yes. When you look at standard tech startups today, many of them borrow an open source AI framework, pull an API, wrap a nice user interface around it, and call it a product.
Right, kind of superficial tech.
Cynlr didn't do that.
Yeah.
In that Bengaluru HIV lab, their engineers literally sit down with paper and pencil and reason through the fundamental physics of how light bounces off a curved metallic surface.
Wow, literally paper and pencil.
They map out the biological mechanics of how a human hand exerts force. They do all of this before they ever write a single line of code.
So they're building the sensors, the hardware, and the computational models from the absolute ground up. The dossier noted they even partnered with the Indian Institute of Science's Vision Lab to actively merge brain science with robotics.
Exactly, and that explains why their hiring acceptance rate is a punishing 0.1%.
0.1%. That is wild.
You can't just be a good coder. You have to be able to think at that foundational physical level. And despite those massive hurdles, they have set very clear, aggressive milestones.
That fits the target.
They're targeting a $22 million revenue milestone by 2027, with the ultimate operational goal of scaling up to deploy one complete robot system every single day.
Deploying a robot a day? I mean, that would fundamentally validate the entire thesis. And for India, the macro implications are staggering.
Game-changing.
We are talking about a transition from being a country that primarily provides the labor to assemble advanced things designed elsewhere to becoming a country that originates and exports the underlying foundational technology that runs the world's factories.
It creates an entire ecosystem of high-skill, sovereign, deep-tech jobs. It breaks the dependency.
It really does. You move away from reliance on a foreign club of robotics giants who produce rigid single-task machines that just keep the power of manufacturing highly concentrated.
Right, and you move toward a homegrown object intelligence layer developed from first principles that gives robots human-like sight and dexterity. That is the necessary bedrock for these universal decentralized microfactories we've been discussing.
It really forces you to reevaluate the physical world around you. Next time you pick up a perfectly assembled product, whether it's the smartphone in your pocket, the coffee maker on your counter, or the steering wheel of your car, think about the incredibly complex, rigid, and essentially blind robotic arms that currently dominate our world to make those things.
It's crazy to think about.
And then think about how entirely that landscape is going to shift as machines finally learn to open their eyes and see the world the way a child does.
And that actually leads to a rather provocative thought that I want to leave you with today.
Well, let's hear it.
We've spent this entire time talking about the factory floor, right? But if Cynlr successfully teaches a robot to see, understand, and handle any unknown object perfectly without any prior training or rigid environments.
Yeah.
What happens when that object intelligence inevitably leaves the highly controlled setting of a factory and enters the messy, entirely unpredictable environment of our own homes?
Oh, wow. That is a fascinating frontier. Like a robot that could finally fold your laundry or do the dishes because it actually understands what a crumpled shirt or a slippery wet plate is, rather than just executing a blind, pre-programmed motion.
Precisely. The home is the ultimate edge case.
That is wild to think about. Well, we want to thank you so much for joining us on today's deep dive into Cynlr, the Universal Factory, and the fundamental future of robotic vision.
It's been a real privilege dissecting this topic. Remember to keep questioning how the everyday things around you were built.
Until next time, stay curious.